I will just run through the basics of quality modeling. So first I will show something on PowerPoint here, just to run through the concepts on what I'm trying to explain in these 15 or 20 minutes. So we might be running a bit late, but check back the recording if you can't hang till the end. So as James said, first I will go through these points in PowerPoint. So what's the kind of the basic principles of simulating quality and chemical load, and then on assessing the load to treatment plant, and then investigating some system reaction times. First of all, simulating chemical load. So in the model, the chemical comes into the system as pollution components, and they run through the conveyance system to outfall or exit, or there might be some treatments in the conveyor system. The treatments can also change a chemical to another pollutant, so they might introduce new pollutants like during the conveyance. The pollutant enters the system with inflows, so rain, groundwater, infiltration, or dry weather flow. The most important parameters for these pollutants are concentration and decay coefficient. For the treatments, they remove different pollutants according to the set functions. In my simple model, I will only model the inflow to the system and some decay coefficient. I'm not going into treatments in this short presentation. The transition into another chemical could be, for example, nitrification and denitrification in the process if the weather and the temperature is right in the system. We're assessing the load to treatment plant. So usually the basic parameters for sizing treatment facilities are BOD, so biological oxygen demand, total nitrogen, and total phosphorus. So in Finland, we have example these like basic sizing parameters for BOD, 50 grams per resident per day, phosphorus 2.2 grams per resident per day, and nitrogen 14 grams per resident per day. But these vary from city to city and from country to country. So for example, in the States, these are a bit higher because they have these ground garbage in their sewage disposal. So there's more organic matter in those type of systems. In my modeling, I will use these Finnish values, but I think you can find other values online as well. So for example, the BOD, which I will be simulating, varies throughout the day because the load that the residents give changes throughout their behavior, with the curve something like this, being the lowest during the night and highest during the peak days. The typical BOD decay rate that I will be using in the model is this 0.35. So in a day, the 1/3 of the BOD will be decayed in the system. Then in investigating the system reaction times, I have a scenario with a chemical spill happening here and just modeling throughout the system of few pumping stations, transfer lines, and some gravitational lines. So how long does it take to reach the treatment facility there? Why this should be done is that the utilities could identify potential customers that have this type of risk and simulate beforehand the event to find out how long does it take for reaching the treatment facility, what is the concentration at what time here, because it get mixed to other fractions of water in the system. Do we need to skip some unit operation? Example, biological treatment might be skipped because that's the most sensitive part of the treatment facility. And how long we need to bypass that if we do it, and how can we implement any type of removal during the conveyance here at some point. And then of course create guidelines for reporting and for emergencies. So how long they have the customer here time to report back to the utility that there are some pollutant entering the system, so they know to react accordingly. So that's the short theoretical part. I will go into the Fluidit Sewer now. So you should be seeing the UI of the software. So I will open my demo model. So this is not actual network. A few words of the UI. Some of you might know it already, but there are others who don't. So basically, we are usually operating with the map view. I have here two networks. We have result windows that interactively change with the selection that I have. For example, this one shows flows and this one shows depths from the selected components. I can modify and move these any way I want to, just to make the kind of the UI to match my specific liking. Let's go back to the software here. And in this basic overview, you'll see the maximum depth of the wells. So in my model, I have quite a lot of water, just to show you some differences. Then the low capacity conduits are also highlighted here. I don't have any overflows, which would be painted by this magenta color. And I have also a digital elevation layer here colored, so see how the terrain changes. Of course, you can choose any type of visualization on the data that you have in the model. So this shows the cross flows, how much water is flowing daily. And this shows how many water entering the system is pumped and how much energy it consumes in each area. What is the free capacity downstreams from each conduit, and used capacity, how many percent until it's full. These are just these kind of basic features of the software. So next, I will show a few things about the quality modeling. So I'll just activate the quality modeling scenario here. I have two outflows or treatment facilities in my model. Another one has 13,000 cubic meters per day, and the another one has 4,000 cubic meters per day. Something which is useful to model is the age of the sewage. So how long does the water stay in the pipelines in average? In my small model with mostly gravitational pipelines, I don't have that long time. Here, I think is the longest if I see how much it stays here on average. So like 3 hours. If you're modeling long transfer lines and long pipelines, it's kind of nice to see how long the water stays here. It is done as a pollutant with a coefficient of -24. It's a pretty simple way to model the age. The BOD will be modeled as a 330 milligrams per liter, so it's the 50 grams per resident per day converted into typical usage of water in Finland, and the decay coefficient is here. So if I look at the BOD load for these facilities, I get 3,000 kilograms per day on the bigger one and 1,000 kilograms per day on the smaller one. And if I look at what is the concentration coming to the facility, it follows this type of trend. But in my demo scenario, the idea is that this other treatment facility here will be closed, and these will be joined with a transfer line. So I'll just activate another scenario, and which there's a new transfer line connecting these two treatment facilities. And I want to look a little bit about how the BOD load changes to the main facility here. So let me just simulate this. Okay, it's not valid for simulation. In our software, there's a network validator that always checks whether the model is valid for simulation, and if it's not, where are the problems. In this scenario, there are few pipelines, few bumps missing their curves. But that's not a problem. This is something that if you model a lot of sewer networks, you encounter that some of the pumps don't have their pump curves because there might be so old pumps and nobody knows what the type is or anything. So sometimes you need to generate some pump curves to these. And in our software, you have quite good tool for creating it in the tools, analysis, generate pump curves. And I just generated for the selected pumps. So it creates a pump curve that creates 1 meter per second flow with 60% efficiency. So you get an operating point of this. Great, now it should be able to simulate. Okay, it starts to simulate now. You can see the progress bar in the bottom. One thing to know that is different from gravitational simulations compared to pressure simulation, that these tend to be a bit longer in their calculation. But the good thing in our software is that it's totally usable during the simulation time. So I can move around here and do anything I want with other things except changing this scenario. So what I would like to do during this time while it's simulating, I will create a Simatic view. It's a view of kind of showing the results a little bit from different angle than in the actual map view. So we can create diagrams and different type of active components or symbols here that react to the changes of the model. We can, example, have some type of map with some extents or something interesting centered there, and this will change with the results that I have in the model. So earlier in the quality modeling, I was showing the POD load here to this facility. I would like to see the actual amount, not the concentration of POD. So I will create a custom view to show that. So let's have a map here that shows where it is. And I will create this type of time series figure. And then I will add this outflow as a component in the figure. I will select POD here, so it's concentration, and I will add another variable as a flow. So the total amount would be these two multiplied together, and you can create any type of conversions or any other calculations here with as many parameters or anything that you want. So it's really powerful tool to show kind of the values that you want to have. So now I have this graph that shows the POD as kilograms per hour to the facility. What I want to do is to, when the simulation is completed, to compare this result to the scenario where we have the transfer line connecting these two treatment facilities. So, okay, I will leave that to simulate and check the chemical spill scenario that I was wanting to show you as well. So here in this scenario, we have a chemical spill happening in this part of the system. And we would like to see what are the reaction times and at what pace will the chemical spill reach the treatment facility here, and how long will the spill be. So I have simulated it with the quite big concentration and with a pattern that's not constant. So you can have a pattern for this chemical spill that kind of simulates so it will be 50% at 6 a.m. and it will rise gradually to 1 and then decline a bit faster. So if I take some junction or pipeline here and show the result of chemical spill, I can see that it loosely correlates to that. But I would what the idea of this simulation was that I would show how the spill advances in the network. So I will just go to the right point in time. Then you can see how the spill concentration kind of runs through the network, through the pumps, through the transfer lines, and reaches the treatment facility here at around 10 a.m. And one thing with everything in our software is quite nice. If you create a visualization that is kind of interactive and changes throughout the time, you can easily create animations from that. So, okay, the simulation is now complete. Let's go back into that in a few seconds. What I would like to do is to create a simulation out of this, just to explain the event, for example, to the customer here or some other stakeholder of the utility. So I will just select this and press this record button, and here you can create the simulation of 20 seconds from this selected map view with this selected visualization. So it takes a while to create that, but I don't wait for it since we are a little bit on a hurry. I have created this beforehand, the video. So let me just show it to you. So you will end up having a video like this. And of course, you could create the video from the custom views or anything that you select. So it's pretty easy to create material that might be useful for reporting purposes or for communicating different things that you do with the model. Okay, let's go back to the transfer line. So here we should have the results. Let's take the Fluidit 8. Okay, now we have a little bit different result on the Fluidit 8, since it takes quite a while to pump the Fluidit from here to the through the new transfer line to the new treatment facility. So you end up having 6 to 7 hours, not that bad. But if you're, for example, examining could there be possibility for like sulfur compounds to form, this H is one parameter to consider. Of course, the anaerobic composition and such should be considered as well, but the H is one thing to look at. Okay, then the POD load. So now all the POD will of course go to this facility, and I would like to check what is the POD load now per hour. But of course, you cannot see anything from this compared to the previous situation. So what I would like to do is to just duplicate this series and compare it to the scenario before connecting these two treatment facilities together. So we can see the difference. So the blue line is when there was not the transfer line, and the red line is the new connected line. Of course, there's a lot of pumpings now, which also creates a lot of variance to the BOD that is coming to the treatment facility. But yeah, I think that was the like the quick presentation. And one thing that I would like to show to you, that even though the simulation times might be long in sewer systems, it's easy to simulate multiple scenarios, just selecting them and simulate all selected scenarios. So now you can just leave this to simulate and maybe take a cup of coffee or go to lunch, and it will simulate all the selected scenarios. But we will not wait for that. now, but just to show you some features as well. So I think that's it. So if you have any questions or anything, I'm happy to answer those.
Awesome, yeah. Thank you, Kalle. And the floor is open if anyone wants to put anything in the chat. If there's anything you would like us to take a second look at or go back into, then feel free.
Yeah, of course, the simulated chemical event was quite simple for me. And if you have any kind of specific problems that you are looking into, feel free to contact us and let's figure out a way to do your specific case.
Completely. Well, if there's no questions in the chat, then not a problem. I'll just wrap this up because we did agree that it would be up until half an hour, so we've only got a few minutes to go. But as I said at the start, we've recorded this, so we're gonna put it up on YouTube. So more than welcome to see that tomorrow. It'll be up online, and maybe share it around with colleagues. And you can also see more resources on our website, which you can just find at fluidit.com. But to say a few words for those of you that are still here and are interested in potentially exploring what our software can do for you and what our services can do for you. As I mentioned at the start, we have both rental and perpetual licenses. So rental is you're paying month to month, cancel anytime. Perpetual is you get to own it forever. And with our licenses, it's pretty straightforward. You just have a sewer license and it's completely unlimited. So you can have a 3,000 kilometer network if you want, or however big or more complex. However that ends up looking is completely fine. And it's floating, so it can be moving between different computers, and doesn't have to just be fixed in one spot, one location. And really, yeah, if there's the interest, then you could reach out at sales@fluidit.com. And then otherwise, for those of you that just enjoy the knowledge sharing and enjoy the learning process, we're certainly going to have another one of these webinars on hot shit. You heard that right. It's going to be reclaiming heat from sewer networks and combining sewer networks with actually energy systems in cities. So that'll be taking place near end of May or start of June. So if there's any interest, then you can certainly find that on our LinkedIn. And here's just a couple of references from some of our clients in Finland and around the world. But I hope you enjoyed yourselves this afternoon, and we'll be hopefully seeing you again soon. So thank you very much, everyone, and thanks, Kalle.
Thank you.
Awesome. Cheers.